Graded 3 students, we are continuing our statistics lesson. Last lesson was over sampling and how we saw that random sampling is the only true way to eliminate bias in a study. Okay, so today we're going to be talking about experiments and observational studies, learning about those, and you'll have another worksheet that'll be due. So let's go ahead and get into it. All right, so if you would, to start things off, we're going to go ahead and write down these two definitions. You have what's called an observational study and an experiment. So I'll pause and let you write these down. Okay, so you, without a doubt, have heard and have probably worked in a science class with an experiment. So I asked some of my in-person students that I've already taught this to describe an experiment that they've had, that they've done before in a science class. So one of the ones that I liked the most was this very simple one where you take ice. If you want to add this to your experiment definition, this is an example here. Okay, you take ice. Okay, and then what you do is you add different types of salts. Okay, and then you're measuring the melt time. And you may remember doing something like this. This is something that's very simple science, and it's probably happened, earlier on in your science careers, elementary, middle, intermediate, whatever. This one's not too complex, but it definitely explains what an experiment is very well. And as our definition says, it deliberately imposes some sort of what's called a treatment. Okay, so we're going to write down the word treatment and define it in a second. So what is a treatment? That in a second, but that would be these salts. You are deliberately imposing a treatment on individuals. So the individuals here would be the ice, and the responses would be the melt time. So you always have individuals in your studies. You always have responses that you're looking for. And sometimes you have the explanatory variable that is something you impose, or maybe it's something you don't impose. Okay. But that's that treatment, or that idea of a treatment, is what makes the total, it's the complete difference between the observational study and the experiment. So an observational study observes individuals and measures variables of interest, but does not attempt to influence the responses. So very different. Okay, very different. So let's go ahead and write down the word, or the definition for a treatment. So we have the treatment is a specific condition applied to the individuals in an experiment. So go ahead and write that down. I'll make sure I pause and you're able to write it. We've got this idea of a treatment. And that's what you're looking for when you're reading a problem and trying to identify. So this is actually one of the iMath 3 standards, is being able to identify the difference between those. Okay. So let's go ahead and pull up your worksheet here. And I'm going to write on this. So in here, we have these examples. Each of the following study descriptions identify whether the study is a survey, an observational study, or an experiment. We're not really worried about the surveys right now. Be observational study or an experiment, and give a reason for your answer. For observational studies, identify the population of interest. For experiments, identify the treatment and response variables. So I'll read through each question, and then you guys will work on this, try to answer them on your own. Okay, that's going to be what we do. Okay, so the first one, it says researchers investigated the link between the use of cell phones and brain cancer. There are two variables in the study. One is the extent of cell phone usage, and the second is whether a person has brain cancer. Both variables were measured for a group of people. Okay, so we'll pause and you will have a chance to answer this one, either observational study or experiment, and make sure that you include the other things that we need if it's one or the other of those. Okay, so this study here is a observational study. Because they're not actually, and the difference that you need to know here is whether or not they are applying a treatment or not. Are they applying a specific condition? They're not here. They're just they have people in this study group. They can only ask them, do you use a cell phone? Or excuse me, how much do you use your cell phone? So we assume all of these people use cell phones. So how long are you using the cell phone? And then, do you have brain cancer or not? Or do they develop brain cancer, right? That's the difference, okay? So observational study, it's a good example of an observational study. What we have to make sure we do is we identify the population of interest. So what is the population? That's what we learned about last video. Well, the population, specific about this, is this all people? No, not necessarily. We got to be a little more specific about that. What do we know about this group of individuals? Well, every single one of them uses a cell phone. They all have brain cancer? Well, probably not. We hope not, right? But every single one of them uses a cell phone. So this is cell phone users that they can say is their population. So this is a sample of those of people who use cell phones. I had students try to say, okay, well, this is actually people, it's representing the people who have brain cancer. Well, not every single person in this sample will have brain cancer, okay? But we do know every single person in here uses a cell phone. So this is cell phone users. Okay, we have the next example. So a lot of these stats questions, they're kind of have a lot that you have to read, but let's go ahead and do that. A study was done to answer the question, what is the effect of different durations of light and dark on the growth of radish seedlings? 3 similar growth chambers, plastic bags, were created in which 30 seeds were randomly chosen from a package, were placed in each chamber. One chamber was randomly selected and placed in 24 hours of light, another for 12 hours of light and 12 hours of darkness, and the third for 24 hours of darkness. After 3 days, researchers measured and recorded the lengths of radish seedlings for the germinating seeds. Okay, very long question. I'm going to go ahead and let you try to decide is it an experiment or a observational study. So I'll pause and give you time to do that. Okay, so hopefully you were able to see that there was a treatment being applied here. There was a treatment. That is, so the treatment would be the amounts of light, right? And when a treatment is happening, we have an experiment. My handwriting, or my mouse writing, it's not even handwriting. All right, it's an experiment. Yeah, for sure. There is a treatment. As soon as you identify that they are imposing some sort of condition on the individuals or whatever they're researching, it is a treatment. So when we have an experiment, to identify as experiment, we have to define the treatment and we have to define the response variable. So that's not so bad because we did identify the treatment as the amount of light. So amount of light, and they have full control over that. All right, the amount of light. So then what is the response that they're looking for? Well, the response would be their response, they're recording the lengths of the radish seedlings. So the lengths of seedlings. Oh my goodness, the writing. The leaks of the seedlings. Okay, so we have that. Now, let's talk about a couple things with these experiments, and why would there be a reason to do an experiment versus a observational study. Well, let's talk about let's just go back to this one here. Okay, they investigated the link between the usage of cell phones and brain cancer. Okay, they did not impose a treatment. Okay, they didn't force them to do anything. But what are they trying to show as the explanatory variable here, where they're trying to find a link between using your cell phone, brain cancer being caused, okay, from as an effect of that. So we have this idea called causation, all right? And that's, with a experiment, it would be very easy to say that light, because we've controlled everything so well, the amount of light would actually affect the growth of these seedlings, okay, the links of the radish seedlings for the germinating seeds. But what's here in this one, in this example, we can't force people to do what? Well, we can't really force them to use their phone for certain periods of time, especially if we think that it's going to cause brain cancer. That would be a bad thing, right? Like they could become hurt, right? They could die from it. And a good example of this would be, and I'm going to go full screen for this. So a good example of a observational study in real life would be how they figured out that smoking causes cancer. It wasn't always thought that at first, and cigarette companies fought it tooth and nail until finally they were able to show causation. But why can we not run an experiment to see that smoking causes cancer or kills people, as an experiment? Well, it's unethical if you think about it. We can't force people to smoke. So we have to use these observational studies to observe people who do smoke versus those that do not. But the problem is, with observational studies, you don't have that element of control. And you probably remember hearing about the control groups. In that ice experiment that I had the student suggest, they had said, well, or we said the control would just be you put an ice cube that just sits in the room on a plate, just like all the other ice cubes, except the other ones were putting salt on, and you really can see that there's a difference. But control groups in these observational studies, we can't force them to not smoke. Let's say that they wanted to start smoking, or dipping or whatever. We cannot force them to not do that, okay? Just like we can't force the smokers to not stop. Okay, so what if a smoker wanted to stop? Well, it'd be unethical to say, no, you can't. We need you for this experiment. So no, that doesn't work. So for examples like that, these big, anytime there's an ethical concern, you have to do what's called an observational study. So that's where those come into play. Okay, now there's an issue with observational studies versus experiments. So let's go back to our slide here. Let me back it up. Go back to this. So in an observational study or an experiment, we're able to show what's called causation. I add this to your notes here. Causation, which is that cause and effect relationship. You've probably heard of that. I'm really on fire with my writing today. So experiments are able to show causation. However, an observational study is only able to show what's called association. Not as powerful. And association is not even close to being as powerful as causation. And you may have heard that term before. Association does not imply causation. You probably will hear it again at some point, especially if you take like a psychology class in college at some point. That will be something that is said. Okay, so you have this idea of association. So, and one observational study does not prove anything, okay, from a statistical standpoint. Yeah, it really doesn't. Because you have this idea on this next slide called confounding. So this is really what, like, let's say we're talking about cigarettes, where those big tobacco companies were saying, okay, you did an observational study because they had to, they couldn't do an experiment, and you have this idea called confounding. So the companies, they had a lot of money invested inside of this, inside of cigarettes. I mean, it's just how it was, So when they said, hey, smoking is causing cancer of the lung, here's what they said. They said, oh, wait a minute. Probably not our cigarettes. It's probably that they live in a highly polluted area. That's why that's happening. Oh, well, okay, we couldn't control where they lived, right? It's not an experiment. We can't control that. So, okay, I guess we have to sort of go back and figure out another way or figure something out to help us out here. And then another one could be, okay, well, they're genetically supposed to develop cancer. That's another thing that we say confounding. So we're going to write down this definition for confounding. It occurs when two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. So two variables, smoking, genetics, those are related in such a way that we can't tell which one. See, the response variable, they have cancer of the lung or they don't. So cancer of the lung, we can't tell which one is causing that, right? That's what confounding actually is. What's actually causing this response that we're getting? That's confounding. So I'm going to pause and make sure you have that written. Experiments are able to prevent this confounding, okay? So observational studies of the effect of an explanatory variable on the response variable fail because of confounding. So that's why these fail. So how in the world did they get to prove this causation of smoking and lung cancer? Well, it took a long time. It took a lot of money. It took a lot of resources, a lot of data collecting, and over 10,000 studies were done over a long period of time. And if you have all of the studies saying the same thing, it's consistent association, eventually you can say, okay, there is causation here, but it just takes time. So we're sort of at that state with vapes right now and vaping. We can't force people to vape. We can't run an experiment. So we, again, have to just do these observational studies. It just takes time to get those to work, okay? All right. So hopefully that's making as far as these types of studies. So now we're going to look at 3 studies here. It says, suppose you want to investigate the effects of exercise on the blood pressure of students in your school. I've thought about 3 different study designs. Classify each design as a sample survey, an experiment, or an observational study. So we're going to write down a definition for a sample survey. So you're just going to write down work. Come on now. 1 second. Got it. Okay. So I'm going to pause, write down this definition for a sample survey. Have it in your notes. All right. A sample survey is a study that uses an organized plan to choose a sample that represents some specific population. All right. So you have that written. Let's go ahead and look at the examples down here. We have 3 studies, and I'm going to pause, and I need you to so that it's a little easier to see. There we go. I'm going to pause, and you're going to identify each. So you'll put study 1, study 2, study 3, or if you've printed this out, this is going to be on Kidem, of course, but print this out, and you can put sample survey, experiment, or an observational study. So I'm going to pause and let you guys take a moment to read each one of them. There's a lot of reading here, and identify them, label them properly. Okay, so sample survey is a little bit strange. It is, and in a lot of cases, it sounds just like an observational study. So we're going to identify first which one is the experiment. That's the most obvious one to actually figure out. So the experiment in this one is going to be study 1, because in study 1, they get these volunteers. You divide them into 2 groups. One group does not exercise, so you're enforcing this treatment, don't exercise. The other group, you say you must do at least 30 minutes of exercise each day in that week. So you're forcing them to exercise. They have to do it. At the end of the week, you find that everyone complied with your instructions. Good, they did that. You then take each student's blood pressure, and you find the mean blood pressure is lower than those that did not exercise. So that is an experiment. So you can label that one experiment for study 1. So that one's pretty easy. Now, looking at these next two, I'm just going to go ahead and tell you which one is which. Make sure that we had an example for each of these, and that's what the purpose of this is, and then you're going to be working a lot on your own moving forward. So for study 2, let me actually write on here. Go here. I'll put E for experiment on that one. So for these, between these two, if you had said for study 2 that it was an observational study, then that would be correct. That's what I've gathered from when I've worked with this with students. I actually don't have the answer key to this sheet, but it has a lot of really good examples, so I like those. And then study 3 would be the sample survey. And the reason that we came up with that as our answers is because how specific the way that they go about this study 3. So you discover that the nurse in the health office at your school has taken the blood pressure of 157 students who have visited the health office over the past year for a variety of reasons. In some cases, they felt sick. In other cases, they had to turn in routine paperwork. You get the names of these students and have them fill in a questionnaire about how much exercise they get. You find that the mean blood pressure of each student who exercise more is lower than those who exercise less. So because there's this specific way that they went about sampling, that's why I think study 3 would be a better description of a sample survey. Here, they do a random selection to eliminate that bias, right? This is not a random sample here. This also is not a random sample in study 1. So there's a lot of bias in study 1 and study 3. But study 2 does a good job about picking randomly. You take students, have them fill out a questionnaire about how much exercise they get. You divide these groups into those who exercise a lot and less. You find the mean blood pressure of students who exercise more is lower than the mean blood pressure of students who exercise less. Okay, so that is definitely, it sounds very much like an observational study where you're just recording it, but they do a good job of setting up the comparison groups in there. Okay, all right, so to continue, and what you're going to be working on will be exercises 1 through 3. So you have 2 pages here, and you're essentially doing some of the same things that we've been doing. You are identifying whether or not the scenario represents a observational study, a survey, observational study, or an experiment, given a reason. Make sure you identify, for observational studies, identify the population. For experiments, identify the treatment and response variables. So I'm going to go ahead and stop my lesson there. You guys are going to be working through each one of these and trying those on your own. You'll be submitting that on Kitum. Either you'll do it by paper, or like if you put it on notebook paper, or you can print this off and write in it. So if you have any questions, please let me know, and I'll try my best to get back to you and answer those.